Alright guys, so let's try this first time. So this builds on what we have learned before, but it's the same steps literally. Alright, so first step, look at the denominator. Is it fully factorized? X squared cannot be factorized anymore, so we know by itself this is a quadratic root, which is good, right? This, however, we need to check to see if this could be fully factorized, right? So luckily when I put this in my calculator, it gave me real and distinct roots. If you put it in your calculator, you notice you get decimals and whatever. Don't use that. Just use your quadratic as a quadratic root. If you notice you're getting whole numbers like 2, 3, 4, and 5, -2 and 1, beautiful. So that means you could break it down into linear roots. Yeah? So luckily when I put this in my calculator, I actually get two linear roots. So just rewriting this here, you'll just end up with 2x plus 5 on the quadratic roots by the two linear roots. Yeah, so nice. Step 2, we need to rewrite it in its partial fraction form. So there's a quadratic root, so you'll know to write that as ax plus b on the root plus, and we have two linear, so we know this will be c over the first one plus d over the second, right? Step 2, complete. Right? Step 3 now, we have to basically get rid of the denominator, right? Remember the little trick I showed you? It has multiplying both sides, but whatever the denominator is on this side, right? So obviously on this side it will always cancel. So you'll be left with the numerator on that side. And on this side here, remember the trick I showed you, when you multiply this by this side, for each term, you'll be multiplying by every other denominator except the one it is over. So for ax plus b, it will be ax plus b multiplied by all the other denominators. So the x plus 1 and the x plus 4. If that confusing, if you multiply this by x squared, x plus 1, and x plus 4, for the first, this one here, x squared will cancel with this x squared. So you'll end up with x plus 1 and x plus 4. For this one here, the x plus 1 will cancel with this x plus 1. So you'll end up with x squared and x plus 4 multiplied by c. And for this one, the x plus 4 will cancel with this x plus 4. So you'll end up with d by x squared by x plus 1. So it's basically every other denominator except the one it is over. So for c now, it'll be c. This will cancel. So you end up with x squared by x plus 4. And then plus d, and same concept, all the other denominators except one it is over. Yeah, and it's right. So A, B, C, and D. So nice. So now we could use a mixture of the methods. Yeah. So I'm going to check to see if I can actually get one to disappear. So let's see. If I let x equal to 0, this will go, this will go, and the A will disappear. So I'll be left with B. So I think I'll just use them. So to start, so when x is equal to 0, this will go, this will go, and the A will go, and well, this will be 5. So it'll be 5 will equal to B, but the A will disappear. 0 plus 1 is 1, and 0 plus 4 is 4. So therefore, B will just equal to 5 and 4. Yeah, so that's good to start with. Don't think I could plug in any other x's to get it to disappear. If you're seeing it, you could try it. Should boil down to the same answer. All right, but at this point, I am just going to expand and equate coefficients. Yeah, so this would be 2x plus 5. So this might be a little long. Just try it if you want to while I'm doing it. So expanding, so x squared plus 5x plus 4. Then there'll be plus c, open bracket, there'll be x cubed plus 4x squared. And there'll be plus b x cubed plus x squared. Yeah, so let's continue now. So 2x plus 5 So let me expand all this. So ax by ax squared will be ax cubed. Ax by 5x will be 5ax squared. And ax by 4 will be plus 4ax. Then b by x squared will be bx squared. B by 5x will be plus 5bx. And b by 4 will be plus 4b. Yeah, I think that's all. And then the c now will be plus cx cubed plus 4cx squared and plus dx cubed plus dx squared. All right, so now at this point, we need to group like terms. So the 2x plus 5 will stay just so. Group all the x cubes. So x cubes now we have a crossed out, going down, going down, going down, going down. We have c crossed out, going down, going down. We have d crossed out. Now the x squares now. We have 5e crossed out. We have plus b crossed out. We have 4c. And we have d crossed out. All right, what else we have here? We have the x's. X, well, we have x's. 4a crossed out. 5b crossed out. And I think that is all the x's there. And then the constants, where we have plus 4b crossed out, and that is all, everything crossed out. So that means we have counted for everything that we need to account for. Right? So nice. So now we could do a little bit of manipulation, right? So remember, we have an x cubed term, we have an x squared term. So we could just write some dummy variables on this side to make it easier. Right? So we could say 0x cubed plus 0x squared. And we'll obviously plus the 2x and plus the 5. It's still the same thing, it'll just rewritten in a nicer way. So you could equate coefficients easier, right? So it'll be x cubed, a plus c plus d plus x squared 5a plus b plus 4c plus d plus x 4a plus 5b plus 4b. Nice. So now we could go ahead and equate coefficients of x. All right, so that's right. So I'll scroll up. So I'll scroll up a little. But that is really all I need. So right, so you say equating coefficients of x. All right, so yeah, so we have 0x cubed, and that will equal to x cubed, a plus c plus t. For that 1, and we have 0x squared, and that is equal to x squared 5a plus b plus 4c plus t. Then we have 2x. Oh, forget to number this one. So we have 2x is equal to x 4a plus 5b. Name that 3. And then 5 will equal to 4b. Name that 4. Right. So now that's we can rewrite it in a nicer way. So for this piece here, cancel the x cubes. So you'll have a plus c plus d. That will equal to 0. For this one, cancel the x squares. So you'll have 5a plus b plus 4c plus d. That will also equal to 0. For this one here, cancel the x's. So you'll have 4a plus 5b. And that will equal to 2. And then for this one, well, we already know what b is. So 5, 5, which is verified because we had gotten the above. All right, so we have equations. Obviously, we know we need to solve it simultaneously, right? So obviously, if your calculator could solve these simultaneously, well, you get through. I'll just show you a little long. So let's go. So take a little while, but stay on the train. We almost finished. So we need to get basically A, C, and D because we have B already. So luckily, we could plug 8 into 7 to get what A is. And then once you have A and B, we could plug it into 6 to get what C is. And once we have C, we could plug A and C into it to get D. So that is the idea we're going with, right? Alright, so let's start it here. So let's see. So substituting 8 into 7. So if we substitute into 7, you'll get 4A plus 5, and B is 5 on 4 is equal to 2. All right, might not have enough space, but we'll see. So we have 4A plus that'll be 25 on 4 is equal to 2. All right, so we end up with 4A is equal to 2. Subtract 25 on 4. So let's whip out the trusty calculator. So 2 subtract 25 divided by 4. So I end up with, so this will be 4A is equal to minus 4.25. So therefore A will just equal to minus 4.25 divided by 4. So you divide that by 4. So that'll be equal to negative 1.06. Yeah, so sadly we have decimals, but small thing. So that is 1. So we have A and we have B. So I'll just write what we have on top here as we go along. We have B as 5 on 4. So we need C and we need D. All right. So nice. So we have A. So we could plug this. So we have A. We plug A because we know we have A. We have B already. We just don't need this. So which one we could go into here now? So we could try this one because we know what A is, B is. Oh wait, no. Okay, so I know what to do then. So we need to plug in A and B into this, and we could plug A into this, and you'll just end up with a simultaneous equation, yeah, with C and D. And then we could just go again. So let's try it out. So if you plug A and B into this one, so before by 1.06 plus C, no, yes, B is 5 on 4. All right, plus 4C plus D is equal to 0. All right, and then we call this one 9. And then the other one will be 5, that's E, so it'll be 1.06 plus C plus D. And now that's equal to 0. Nice. So now we can just simplify this quickly and solve that. Luckily, we can C and D one time because they're just a simultaneous, right? So I just solve that quickly. So we have 4 by 1.06. So 4.24. So just put a little divide and we'll go on to the next piece of the screen now. So, all right, so nice. So we'll have 4.24 plus 5 on 4 plus 4C plus D is equal to 0. So you can just simplify that one time. So plus 25, well, sorry, 5. So that'll be 4.24 plus 5 on 4. And you get 5. So that's carried across one time. So before C plus D, now that's equal to minus 4. So for my 5.49. All right, so that's one. And then the other one now, what it was this here. So we could just, so the C plus D, that's equal to minus 1.06. So it's 10. This is 11, and this is 12. All right, so now we could finally solve them simultaneously. So if you write it one on top of the other, so you'll have 4C plus D is minus 5.49, and then we'll have the other one, so it'll be C plus D is equal to minus 1.06. All right, so now we could solve them simultaneously. So solve them simultaneously. So let's see. So let's see. So we can transpose 14 for C and plug it into 13, or we could transpose 14 for D and plug it into 13. So I'll transpose it for D because that's the easier thing to do. So D will just equal to minus 1.06 minus C. And you put that into the one on top. So it'll be 4C plus open bracket minus 1.06 minus C, and that's equal to minus 5.4. Nice. So expanding to 4C be minus 1.06 minus C is equal to minus 5.49. So let's see, so it'll be minus 5.49. And when I calculate this, it'll be plus. So it'll be plus 1.06. So that'll be minus, so 4C. So 4C minus C. That's equal to minus 4.43. Obviously, this will be 3C is equal to minus 4.43. And let's say divide both sides by 3. Minus, so C will be minus 1.47. All right, so now that we have C, we can just plug it into this equation, into 14. So, um, so you say when C is equal to minus 1.47, I don't look at it now. I don't look at that. So getting weird. All right, yeah. All right, so plug it into 14. Now we'll have minus 1.47 plus D is equal to minus 1.06. So carry this on the other side. So you end up with minus 1.06 plus 1.47. So D will be 0.47. All right, was a little long, but we got what we wanted. So C is minus 1.47 and D was 0.47. Yeah, so now we could finally write any part of practice one. So obviously I'm not gonna write the first piece. So that's equal to A, or A is 1.06, and that was over, so it'll be, I think it was AX plus B. So it'd be 1.06x plus 514. All right, so all over x squared plus C, or C was minus 1.47. So that'd be minus 1.47. Minus 1.47. What was the root for C? X plus 1. And I think the other one was minus. Oh, this X here. That'd be plus 0.47 over the root for it, which is x plus 1. All right, so that'll be the answer right there. Yeah, so hope it helped. It's the same steps. All right, so be safe, guys.